In the previous lecture, we have introduced the different concepts of central tendency, and let us discuss a little bit about the measure of dispersion, and from there we can conclude for this session. So, any query related to the class, whatever topic that we have covered? So we have talked about the measure of central tendency as mean, median, and mode. So mean is the average in usual sense. Median is the middlemost point of the distribution. If you collect the data, then also it is the middlemost point. And mode is the value for which probability mass function or probability density function so mode I have drawn this side. Yeah. Mode is the value for which the probability mass function or the probability density function attains the maximum height. So these are the three measures of central tendency, and we have talked about skewness, and it is if the longer tail is on the larger side of real axis, it is called the positively skewed. If the longer tail is to the lower side of the real axis, then it is called negatively skewed. We will see the measurement, how you can measure it. Just visualization is not good enough. And the order of mean, median, and mode, they alter depending on the positively skewed or negatively skewed distribution. If it is a symmetric distribution, then it is expected, and unimodal, if there is only one mode, then mean, median, and mode will be same. So for example, you can see that these are two nice distribution. So if, okay, I'm not telling you the name. If X has PDF, this e to the power minus half x minus mu by sigma whole square root 2 pi by sigma. And then mean, median, mode are same. Similarly, if X has PDF, e to the power minus mod X, then also mean, median, and same as mode. But another interesting distribution that we have already introduced is this. What should I say? If x equals to 1 by pi 1 plus x square. For this distribution, if you have this PDF, then median equals to mode, but mean doesn't exist. Okay. So this is, I will come across this distribution once again when we will study the special distribution. This is known as the Cauchy distribution, this is known as the Laplace distribution or double exponential, and this is known as the normal. But anyway, so these are few examples, there could be many.
Yes, please.
Yes,
Could you please explain how the mean does not exist for the third case?
So you have not done that homework, right? Where it is? I have already given you. It shows that our students are not following our lectures. It is discussed, I think, 2 weeks back. Uh, yeah, here already you see I have given you long back this exercise. So it clearly says you are not with me. So anyway, you study this integration minus infinity to plus infinity mod x 1 plus x square dx and check whether it is going to a finite number or it is going to infinity. As simple as that. Is it okay?
Okay, sir.
Okay. So at least what is happening to the other section and other courses I don't know. But let me make you clear that whatever I do in one lecture, that is going to be used in a lecture in the future. So if you think that it is a just discrete process coming and going for the lecture, it will not happen. And so you make yourself prepared accordingly. In any course of mine, whatever I introduce in previous lecture, that will be followed in the next lecture. And the course is designed in that way for my lectures. Okay. Anyway. So these are the thing. Now let us also, so central tendency part we have covered. Now let us talk about the measure of dispersion once again. So it is usually people go by the variance. So variance of x is expectation of x minus mu x whole square. It is expectation of x square minus mu x square. Okay, always if exists. Now, another measure of expectation is also used. Instead of this is used as a square distance. The distance measurement is very much important. How you define the distance. Whatever you have studied so far, Euclidean distance or absolute distance, but they are not the only way to define distance. There could be many other ways to define distance. Even in real and forget about real line is not such variation, but in higher dimension when you will go for Rn, there will be many different ways of measurement of distance, and they are essentially important when you are dealing with statistics. Always using this square distance and absolute distance is not good enough, and very often they are misleading. And that is found that many practitioners of machine learning, artificial intelligence, and all those new stuff, they are repeatedly using the wrong notion of distance, and they are coming up with a very bad interpretation of the data. So you have to be careful when you are defining the distance. Another distance is usually, so this is variance, mean absolute deviation. So instead of square distance, we define usually written as MAD, and it is defined as theoretical version is expectation of x minus mu x, sorry, only one, mean absolute deviation, or its data counterpart is 1 by n sum over xi minus x bar mod I. So from data you use this, theoretically you use this. Interesting fact is this: square deviation, we have done this, expectation of x minus a whole square is minimum when measured around mean. That means if a equals to the mean, then it is minimum, and mean absolute deviation, or mean square deviation, mean absolute deviation is minimum, mean absolute deviation, that means expectation of x minus is minimum when around mean. In that way, they are connected. I have asked you to do one exercise to write a code for simulating or generating few data, or you choose 5-10 data points and minimize this function, or maybe something, this function, 1 upon n sum over xi minus a. Have you done that? One exercise I have given in the note.
Yes, sir, the minimum was occurring when for odd size data it was occurring at the middle, and for even size data it was occurring at 2 points, like the middle 2 points.
Or only middle 2 points, or the all points in between the middle 2 points?
Yes, sir, all the points between the middle 2 points.
Yes, so if there are odd number of observations, then whatever may be you are getting, the minimum will be here, then might be you are going to increase this thing in this way. So here you are supposed to get the minimum. But if you have 2k data points, so it will be k and k plus 1. Then for all data points here, it will attain the minimum, and then it will gradually increase. So the point is this, median need not be unique. So all the points between these two, including these two, they all can be median. So median need not be unique. Okay. And that is true for theoretical version of random variable, as well as that is true for the data counter. So median can be more than one. But the thing is interesting that if your sample size increases, then the distance between these 2 points will be gradually more narrow, and as a consequence, the median you obtain from data will go to the true median very rapidly if you increase the sample. So that is a very nice thing, and that kind of property is known as the consistency. So when your sample size increases, your approximated value from the data will go to the true value with a very fast rate or with a very large probability. That is known as the consistency. So any query related to measure of dispersion and measure of central tendency, because they are really useful for your data analysis.
Sir? Sir?
Mm-hmm.
Sir, if we increase the number of data, sir, then also the median will be somewhere between the range of 1, I mean x to x, k to k plus 1.
Yes.
So, sir, how we can approach to the...
No, it is not k to k plus 1. I should say it is xk. I should say x data. I should say xk. It is not the integer k and k plus 1. It should be xk and xk plus 1.
Yes, sir. So, sir, if we increase the value of k, I mean the number of input points, then also it will lie somewhere between xk to xk plus 1.
That is true. That is true.
So, sir, how we can...
But the fact is that the distance between xk and xk plus 1 will be much more narrow. If, say for example, if you draw 5 samples from this, say for the time being, let us assume fixed factor. Okay. 5 samples from 0 to 1, then what will be the distance between any 2 points? And if you generate 50,000 samples from 0 to 1, then what will be the distance between this middle 2 points? Do you get my point?
Yes, sir.
So say for example, if you see this graph that we were, where it is going? MST. Yeah. So if you just see any of these points, yeah. So what could be the distance between any 2 points? I mean, they are very, very less. Any nearby 2 points, if you pick up any point and see the distance of nearby points, they are very less, right? But if I have just, and that is drawn, I think, 10,000 samples. But if I just draw 10 samples from this unit square, the distance between any two neighborhood points could be very large, right?
Yes,
Is
sir.
it clear?
Yes, sir.
Hello?
Yes, sir. It is clear.
Okay. Okay. Very good. Thank you for your question. Okay, so now another measure of, okay, so let us move for mean median mode, variance, mean absolute deviation. Okay, and another thing before we leave, that square root of variance is known as the standard deviation. So square root of variance is known as the standard deviation. It is in theoretical sense as well as in practical sense. I mean data, whatever. And it is always taken the positive square root, not the negative one. Now we are going for the measurement of skewness. Okay. Already we have talked about skewness in the previous lecture, that this is positively skewed, this is negatively skewed. So we are going to measure the skewness. Measure of, that means how much skewed. You need to quantify it. If you cannot quantify it, you cannot use in statistics. Just seeing the data or seeing the diagram, saying something, that is, I mean, needed. At certain stage it is needed, because um, data will not tell you anything. You have to learn from it. But for that you need experience. You need to have theoretical experience as well as practical experience. Otherwise, data is just a dump. It is not going to tell you anything. You need to know how to handle the data and what are the possible measures are there and how you can modify it, what are possible distortion can happen to it with the different source of data. This knowledge comes only through experience and learning from an experienced teacher. The books will never tell you, because so many things are there which are, I mean, true, but not written in the book. So only learning from your experience and the experience of other person will be helpful to develop your idea in the area of statistics and data analysis, whatever you want to do. Okay, so measurement of skewness, it is developed through the help of third order central moment. Okay. So third order central moment is expectation of x minus mu x whole cube, but this quantity is not unit free. Just to make it unit free, what we do that sigma x cube. So mu x is expectation of x, and sigma x square is variance of x. So variance of x is a square term, with unit is square of the unit. So sigma x cube is of the same unit of x, and these two quantities will cancel each other, their unit. So this is known as the measure of skewness. Usually you will find that if, so what should I name? just let me check what is the standard name it gives. Otherwise, beta or gamma, that I often forget. So, or just let the okay, mu3 tilde they have anyway. B1 V1. Okay, anyway, so let us call this thing, this is as mu3 tilde, might be measurement of Qness. And if it is positive, if mu3 tilde is positive, we call the distribution is positively skewed, and if mu3 tilde is negative, we call the distribution is negative distribution. Okay, so as simple as that, this is the measurement, and you can use this data counter part in this way. Say m3 tilde is 1 by n sum over xi minus x bar whole cube, I running from 1 to n, whole divided by 1 by n sum over xi minus x bar whole square. So this is the variance. You need to take its power 3 by 2. So this is the data counter. Okay. So from data you have to measure in this way. From theoretical PDF you need to measure, or PMF you need to measure. Now if the moment doesn't exist, you cannot even use this result. So for that, there is another alternative measurement. There are many others, but one is very famous. So let us call QM based on quartile we use. So it is Q3 minus Q2. I am defining what is Q3 and Q2 minus Q2 minus Q1 divided by Q3 minus Q1. So Q3 is this. Probability x less than equals to Q1 is 0.25. 1/4 of the data less than Q1. And probability x less than equals to Q2. Q2 is the median, 0.5. And probability x less than equals to Q3 is the third quartile, 0.75. Okay. Fourth quartile is the highest point because probability x less than equal to Q4 is supposed to be 1. So this is first quartile, this is second quartile, same as median, this is third quartile. So Q2 is median. And now if you see, if you have any distribution, maybe here is Q2, here is Q3, here is Q1. So if it is positively skewed, then Q2 minus Q1, that quantity, this distance, will be less compared to this distance. So this quantity is supposed to be positive divided by the entire gap between the third quartile and the first quartile to make it unique. So this is another measurement of skewness. And if it is symmetric, so for symmetric distribution, that means like this one, this one, this one, for each of them, for symmetric distribution, skewness is 0. Okay, and that is the measure. If you find the measurement of skewness is 0, you can call that it is a symmetric distribution.
Sir,
Yes, please. Yes, go ahead.
sir, if we try to solve the numerator part, sir, then it will become Q3 plus Q1, sir, in the QN formula.
Yes.
Yes, sir. Sir, if we try to solve the numerator part, sir, then it will become Q3 plus Q1.
Is it so? Q3 minus Q2 minus Q2
Sorry,
plus
sir.
Q.
Sorry.
Okay, so Q3 minus 2Q2 plus Q1. Okay. Don't do this kind of mistake in exam.
Yes, sir.
Okay. Another thing of symmetric distribution is this, that maybe say if you say the symmetric around mu in general, mu can be 0 also. So what we say that f of, so x here, that means height at this point. Okay, so let us talk about 0 first. F of x equals to f of minus x, or in other way, capital F of x, or capital F of minus x, that means this region, is same as this region, which is 1 minus f. So this is symmetric around 0. And this is the result, and this idea will be often used when you will do the testing for t distribution, normal distribution. So you need to use some cutoff value or quantile values from the data. So then this symmetry will be often used, and the table that you see from different book and different software, they often give the table for the half of the distribution, other half is automatically implied. Okay, so as the quantile we have talked about, let me talk about a little bit about quantile, because those are very simple things, but if you don't know the terminology, you might be lost. So quantile, these are quartile. They are quartile. That means quarter 1, quarter 2, quarter 3. They are quartile, and these are quantile from quantity. Okay. So this is nothing but the solution of, so if you consider P like between 0 and 1, then pth quanti is, say, xp such that say I should f xp equals to p. That means probability x less than equals to xp is. So in other words, if you have PDF minus infinity to xp ft dt equals to p. So you need to find the solution for this equation. Or if you know the CDF explicitly, you need to find the solution. So if you take p equals to half, it will be median. If you take p equals to 0.25, it will be Q1. If you take p equals to 0.75, it will be Q4, Q3 in this way. But it is in general true for any p like this. So do one exercise. That so suppose a radioactive quantity has an exponential decay, and the decay PDF is this lambda into e to the power minus lambda x. Lambda x is greater than 0, and lambda is also greater than 0. This is your PDF, and 0 otherwise. Okay. So find out, maybe say its median Q2, that is p equals to 0.5. Find xp. If so, this curve is looking like this, exponential. And this is the thing that I hope all of you have seen in your physics book, or maybe physical chemistry book. The radioactive decay rate is described by this curve to describe the half-lifetime of the isotope. So can you please find out half-lifetime? So you have to solve this equation. So this is the PDF. So what you need to do? So integration ft dt 0 to x 0.5 equals to 0.5. So this will give you lambda e to the power minus lambda x, okay, lambda t, let me write, dt integration 0 to x 0.5 equals to 0.5. As a consequence, what you will get, 1 minus e to the power minus lambda x 0.5 equals to 0.5. Now e to the power minus lambda x 0.5 equals to 0. From here you have to solve. So what will be the solution?
693 by lambda.
Say again. sine 3 by lambda, sir, ln 2 by lambda. Half life. So 0.5 divided by lambda, natural logarithm of 50, right?
Yes, sir.
Negative sign is there. Wait.
ln 2 by lambda.
Lambda is out.
Lambda is
Lambda is out of the log.
Wait. So you have to first take log. So minus lambda x 0.5 is log half. So that is minus lambda x 0.5 equals to minus log 2 x 0.5 is yeah. Is it okay?
yes, sir.
Yes, sir.
Okay. So this is how, and this kind of problem you may expect in your exam. Another thing, before we go for the other measurement, so percentile, there is another quantity terminology you might often heard about, percentile. So percentile is nothing but a extended version of quantile. So if I say that 5 percentile, that is equivalent to 0.05 quantile. So 5% is in probability, it is 0.0. So you have to convert it. So if you are given 5 percentile, make it quantile and then you go by this. As simple as that. Any doubt? Because people often not, aware of probability, but percentage notion is very common for laymen. So the things are often described in terms of percentile. So maybe the score of NET exam, GATE exam, or IIT, JEE exam. So percentile is a very common thing to be used there. But to convert the percentile into probability or quantile, then you use this result, it will go. Any query? Okay, then finally the last one, kurtosis. Kurtosis measures the peakness, how peaked it is, or the height of the mode, how far it is increased. The mode is the base point, the height at mode, I should say. So in general, the kurtosis is measured with respect to fourth order mode. It measures the peakness of the distribution. And it is measured with the help of fourth order central moment. So it is defined, let us define in this way. So beta is expectation of x minus mu x whole to the power 4. To make it unit free, we need to consider sigma x to the power 4. That means expectation of x minus mu x whole to the power 4. And here you can also write this quantity, say variance of x whole square. Okay. And it is found, say, if fx follows standard normal 0, 1 with PDF, x with PDF fx equal to e to the power minus half x square by root 2 pi. This is a very common and useful PDF in different distribution, different domain. So then expectation of x minus mu x whole to the power 4 by sigma x to the power 4, this quantity is found to be 3. So often it is measured in this way also, that gamma equals to this quantity minus 3. Expectation of x minus mu x whole to the power 4 by sigma x to the power 4 minus 3. So around 3 also it is often measured, but it doesn't matter if you know this quantity, subtracting 3 or not subtracting 3 is not a big deal. So if you have, this is standard normal PDF, then either the graph will be below it or the graph will be above it. So this is the structure. Can you tell me that whether a PDF, suppose two PDFs are there, both of them are from continuous value random variable. Is it possible that the one curve will be always above the other? Yes or no?
No,
Two
sir.
PDF.
No, sir.
What is the reason?
Sir,
area
because the
should-
area should have to be 1.
Area
Probability will be
one.
more than 1.
Yes, yes. So the area under curve should be always 1. So it will never happen that one PDF will be always above the other. So if you have two PDF, it will always cut. At least 2 points, I think. It will always cut. And PDF always need not be so nice looking. The PDF also can be like this. And this kind of PDFs are very much problematic. One such example, I am not going details, that I told yesterday that all moments exist, but moment generating function doesn't exist. Such kind of example can be constructed with this kind of PDF. Okay, so all the measurements, and I hope you can understand what you need to do the data version for it. 1 by n sum over xi minus x bar whole to the power 4 I running from 1 to n, and then 1 by n sum over xi minus x bar whole square. So this is the data counter. So in this way you can, I think, do all of the necessary work related to the theoretical aspects of the moment as well as the practical aspect, the data version of the moment. So these things like measure of central tendency, measure of dispersion, measure of skewness, kurtosis, they all come under the descriptive statistics. And they all are moment driven, most of the thing, moment driven or percentile driven statistics. So if the theoretical moment doesn't exist, you need to go by the percentile, median, mode. This kind of thing will always exist. Mean may not exist. Okay. So the measurement of this distribution-based measurement, that means median and mode or first quartile, third quartile, all those things are considered to be more robust measurement compared to mean. So if you put one extreme value in the data, mean will fluctuate too much, but median will not fluctuate that much, mode will not fluctuate that much. So they are considered to be more robust measurement for the central tendency. Okay, so let us have 5 minutes break. After that, we will solve few problems. Okay, any query before you leave?
Sir, in the diagram that you have drawn, the graph which is rising above, no sir, the above one. Yes sir, the graph which is sharper and rising above the normal distribution, does that have a higher value of gamma compared to
Yes,
the...
yes. So this one will have higher value of gamma higher than 3. This one will have less than 3.
Okay sir, thank you sir.
And this is for this one. Sorry. If you say gamma, then this will be positive. This will be negative. For normal 0, 1, gamma is 0.
Excuse me, sir.
Yes.
So, is it given that E x minus mu x whole power 4 by sigma for 4 equal to 3, or we shall calculate?
No. If you have this PDF, consider these two lines. If you have this PDF for standard normal, then it will be 3. That can be computed.
Okay.
Theoretically, this value will be 3. Now, instead of just going by the value of beta only, people often compare it with respect to the standard normal. If the height is more than standard normal, you subtract the 3 and say it positive, and if it is less than standard normal, you subtract the 3 and call it negative. I think some forgot the name. One is called mesokartic, another is called platykartic. You just check in Wikipedia which one is called mesokartic and which one is called platykartic. So, it doesn't matter. Only you need to know the numerical value. So, if x follows normal 0, 1, then its skewness is 3. This measurement is 3. So often people subtract 3 and compare it with the standard norm. Is it okay?
Yes, sir.
Okay, so let us have 5 minutes break. What is the time now? Okay, 9:02. So maybe around 9 o'clock 7, we will come back. What should I say? everything we have done. Very good. Okay, so let us do some problems. Only the syllabus is very less, so there should not be very difficult problem. Let us try. So suppose this is given that let x be a real valued random variable and expectation of x is 0, expectation of x squared is 2, expectation of x to the power 4 is 4, and the question is tell me, how will you address this problem?
Excuse me, sir.
Yes, well,
Sir, will the area under the probability density function will always be 1?
say again, please.
Will the area under the curve of probability density function be 1 always?
From which respect are you saying? Area under the curve below the probability density function should
Will
be
be 1.
always if you integrate from minus infinity to plus infinity.
Yes, sir. But previously you also said that the probability density function can be greater than 1 also.
Yes, of course. We have done the example, right?
Yes, sir.
Probability density function is not probability, but area under the curve can be 1. Yeah, you see? Here is but this one, if you see,
Yes, sir. There the value is 2.
yeah, the value is 2. value is 2. So PDF is 2, but you are integrating over this range.
Okay.
Right.
Yes.
Well, how to deal with this problem? Any guess? Because no longer you will get multiple choice question. You have to work it out. You will eliminate two of them, and between two of them you will choose one. That time is over.
Sir, maybe we write e of x square as integral x square f of x, and we differentiate it by parts and use the result e of x equal to 0. And using this, maybe we can find small f of x.
How differentiation comes?
Integration by parts.
No. How does it guarantee that? Which function are you differentiating, and with respect to what are you differentiating?
With respect to small x.
No, here is no small x. All are capital X. They are random variables.
Sir, we can write e of x power 4 as integral.
Say again. Yes.
So then we can integrate by parts.
But PDF is not given to you. What integration will you do?
Let the
So we
PDF
will
be
try
some
to convert it into other
I can't hear you.
moments.
Say again.
Sir, we will try to convert it in the form of other moments.
Okay, that's good. But even though you know all the moments, you don't know, you cannot always say what the distribution is. Well, so let me tell you, it is a really tricky problem, but not difficult one. So, if you consider this quantity, variance of x squared, what will be this? By definition,
1 upon n
E
sigma
of x power 4 minus e of x square whole.
E of x.
so e of x to the power 4 minus expectation of x square whole square, right? Is it okay? Now,
Yes.
what will be this value? E of x power 4 is 4
0.
minus 2 square. This is 0. So you have a random variable whose variance is 0. And so expectation of x square is 2 and variance of x square is 0. What does it imply?
X square is 2.
X square is 2. The probability of x square equals to 2, that probability is 1. So from now, probability of x square equals to 2 and expectation of x equals to 0. These two things, what does it imply?
It implies that x
Probability of
equal
x
to
equal to root
root
2
2
is
and
half.
n should have equal probabilities.
So x equals to
Square root of 2 and
Square
minus.
root of 2 plus 2 and plus square root of 2 minus square root of 2 with equal probability. Probability equals x equals to minus root 2 equals to probability x equals to plus root 2 equals to half. Okay. Now rest of the thing are trivial. What is the expectation of it? What will be the answer?
0.
0.
So could we just say that since e of x is 0, it means that x is an odd function, the random variable function is an odd function. So its expectation of x cube will also be odd function, so it will be 0.
Which one is odd?
If expectation of x is 0, it means that x is an odd function. Right?
X is an x itself is an odd function. If you say fx equals to gx equals to x minus infinity to plus infinity, it is odd function.
Yeah, so x
But
cube would
your
also
trend has to be odd function. X fx
okay.
that has to be odd function, right? Then only state will be.
Yes.
Okay. So any query? This is a very crucial observation. That variance, when variance is 0, that means all the probability is at one point. There is no fluctuation of the data. So it often known as the degenerate distribution. All the mass is at one point. So this is known as the degenerate. Degenerate distribution. Okay. Another example is interesting.
Draw a graph for this.
Yes, please.
Sir, can we draw a graph for this?
Yeah, graph of this. So degenerate distribution here. So if I say that y equals to x square, then it will take value 2 and it will have only one. This height is 1. All probability there. Okay. This is the PDF.
Sir, will that height be 1 or infinity?
Second.
Will that height be 1 or infinity?
I think, yeah.
Will that height be 1 or infinity, sir? Infinity.
No. It is when you have only one realized value for the random variable, it will become a discrete random variable, right? And then you have to have a probability mass function for it.
Okay.
Is it okay?
If it is continuous, shouldn't we think it?
If it is continuous, then there is no chance to have degeneracy. If it is continuous, it had to be distributed over an interval.
Yes.
Is it okay?
Okay.
Other counter examples can be constructed like that. Have you studied Cantor set in any of your courses? Cantor set? Cantor set?
No.
No, then forget about it. There are very nice examples like you can start with 0 to 1 interval, then 1/3, 2/3. Remove this part. Then again consider this one. Then again remove the middle third. Again remove the middle third. In this way you keep on removing. So then the length of the set is this can be converted to 0 itself ultimately. So these kind of things can be done, but okay, so forget about it. If you study some time in future, you will have the interesting fact from here. So now another example, which is also a very nice one. that, okay, so fx given in this way, 1/3 x square when x is greater than equals to 0, strictly less than 1. It is 1/3 if x is greater than equals to 1, strictly less than 2, and it is 2/3 plus 1/3 x minus 2 by 2 when x is greater than equals to 2, less than equals to 4. If this is the structure of CDF, can you please tell me what is the expectation of x?
Sir, 11 by 9.
How? You please tell me.
Sir, integration of x dfx.
Okay, what is dfx here?
Differential of fx
Yeah.
at sub-interval.
So it has a discontinuity at 2, so that's a
Yeah.
problem.
There is a discontinuity, you cannot differentiate it so easily. You can do part by part. So if you plot it, be careful.
Also, sir, shouldn't we mention it is 0 in the otherwise, since CDF is defined over all real lines?
Okay, so you can say that in this way that it is 0 if x less than 0 and it is 1 if x greater than 4. That thing you must think. So what is the point of? So 0 to 1, 1 to 2, 2 to 3, 3 to 4. So 0 to 1, fx is looking like 1/3 x square. So if it is 1/3, then it may be looking like this. Then from 1 itself to 2, it will stay at 1/3. Then at 2, it will jump to 2/3. So there is a jump. And then from here, it reached 1. And then it is always 1. So this is how it does look. And this kind of random variable is known as the mixture random variable or mixed random variable. Okay, now you can do whatever you want to do. So for this part, what will be the PDF?
2x by
2 by
3.
3.
You have to differentiate this. 2 by 3x. For this part, what will be the PDF?
0.
0.
it will be 2. Then you have, what is the probability at 2?
1/3.
1/3. Then from 2 onwards to 4, what will be the PDF?
1/6.
1/6. 1 has 2 x divided. And then integrate out. That means from here to here, you have to integrate 2 into the probability of 2, then integrate from here to here again according to the PDF.
Sir,
So,
sir, how you calculated the probability at 2?
yes, you see, below 2, it is 1/3. At 2, it is 2/3. Here is the jump. How much amount of jump? 1/3 to 2/3. Is it okay?
So, sir, probability of 2 is 1/3.
Yes, because at 2 the probability mass is 1/3, because below 2 the probability reach up to 1/3, and from 2 it starts with 2/3.
Yes, sir. Yes, sir. I got
So
it.
there is a
Thank
jump
you.
discontinuity. Is it okay?
Yes, sir. Thank you, sir.
Often, if the CDF given and you are asked to do something, be careful whether it is completely continuous or there is some discontinuity. You always be careful. So from this part, we will get so expectation of x equals to, technically writing this is correct, integration of x dfx, and dfx here it will split in this way, that x into 2/3x dx, integration from 0 to 1, then plus integration from 1 to 2, 1 to 2, it is flat, so no mass is there, it will be 0, x into 0 dx, plus at 2, so here it is typically 2 minus, at 2 it has a probability, so 2 into 1/3 plus, for this part, the slope will be eventually contributing. So 1/6 2 plus 2 4 x into 1/6 dx. And now tell me please. Oh, how much?
Eleven by 9.
11. whatever comes. In exam, always in decimal. No fraction. Always in decimal. Otherwise, you will not get the number. Nobody will cross check. It will be done by machine. So how much it will be? In fraction? A decimal?
1.22.
And if your answer should be correct up to 3 decimal places, error ranges are usually given 0.005. So 0.005 plus minus will be taken as a correct answer. Your answer should be correct up to 3 decimal places.
Sir,
Yes.
so using definition of continuous random variable that probability of x at any x is 0, how can we tell this given example is a continuous random variable?
No, it is not a continuous random. I have told the mixture random.
Okay. Oh, what does that mean, sir?
Mixture means you might have probability mass at some point, and some other part it might have a continuous density over interval. So for this interval it has continuous density. For this interval there is no probability. For this point there is a probability mass. For this interval there is a continuous density. This kind of bits and pieces will be there.
Okay, sir.
Okay, another interesting example. Yeah, this is a problem from GATE. I don't know which year, but that moment generating function, let the MGF of a random variable x be mxt equals to 1 by 6 plus 1 by 3 e to the power t plus 1 by 3 e to the power 2t plus 1 by 6 e to the power 3t. Okay, so find the probability that x less than equals to. As a simple problem. Not much.
Sir, in the previous question, sir, I am getting a 2 by 3 term extra.
Where?
Sir, on previous page.
This page?
No,
or
the rotate. Next one. Yes, sir, there. I am getting 11 by 9 plus 2 by 3.
Yes, sir, me too.
Yes, sir.
Yes.
This one?
Yes, sir.
Wow. So, oh, please tell me correctly. This is a pretty simple thing. So 11 by 9, if you, is it coming that only from these two parts?
Yes, sir.
Yes, sir.
Yes, sir.
Is it for all? I have not checked it. Okay, then let us make it correct. Whoever has told 11 by 9, please cross check and tell me.
Excuse me, sir.
Plus 2 by 3. So finally, 3, 4, 6, 17. Okay.
What, sir? Excuse me, sir.
Yes.
Sir, while defining the CDF, we took that x 2 less than equal to x less than 4, right? So at x equal to 2, shall we take 2 by 3
So look,
or 1 by 3?
x equals to 2. So here it is given x less than equals to 2, 1 by 3. And from x equals to 2 with equal to sign, it is given 2 by 3 and this.
So shall we take 2 into 2 by 3 or 2 into 1 by 3?
Here.
Yes, sir.
Hello?
By 3
Yes,
is the
sir.
jump.
So here you need to consider the amount of jump because it is a discrete probability.
Okay, sir.
Okay. So in the very first day, you have seen that the step function we have constructed, and the probability associated to that point is amount of jump at that point.
Yes.
So now tell me about this. Can you identify the probabilities and the point where the probabilities are? Seeing the moment generating function. This is also a trivial problem, but we have to identify. I have written plus 1, which one is plus? 2 plus. So what is the definition of moment generating function? Bolo?
E of
Expectation of
E for Px.
yes. Now,
E of
from this expression, can you tell me what are the values x can take and what will be the probability associated to it?
Sir, 0, 1, 2, and 3.
Yes, probability x equals to 0. How much?
1 by 6.
1 by 6. Probability x equals to 1. How much?
1 by 3.
1 by 3. Probability x equals to 2. How much? 1/3. Probability x equals to 3 is 1 by 6. Now it is trivial. Probability x less than equals to 2. This is it. So 5 by 6. As simple as that. It's a doable problem. And okay, another problem. Let us start. Okay, so let me see what you do with it. Say x takes value, x takes angular value. X takes angular value uniformly on 0 to 2 pi. Very even text. This is close. So over a circle, this angle is x. Then define y equals to sine x. You can consider that there is a radar and you are considering its distribution, something like that. They are rotating uniform. So find the CDF and PDF of y. Tell me, how will you address this question? Because the curve that you know sine x, if you plot from 0 to 2 pi, it will be up, down. And to find the PDF, what you need to know, probability y less than equals to small y. What will be the possible values of small y that you need to consider?
-1 to +1.
-1 to +1. So y belongs to -1 to. So first you do in this way, that y belongs to 0 to 1 and y belongs to -1. Separately deal with these two cases. So here it is 1, right? And here it is -1. So if you fix y positive, this is sine inverse y greater than 0. What will be this point?
Pi minus sin inverse pi y.
Pi minus sine inverse y. So you see that the region here to here should be considered, and the region here to here should be considered, right? Because for this region, capital Y is less than this small y, and for this region, capital Y is less than small y. Is it okay? So you need to integrate, because it is told that it is having uniform distribution, and already we have done some exercise. So fx, the PDF is 1 by 2 pi. Pi is running from 0, sorry, x is running from 0 to 2 pi, 0 otherwise. So you need to integrate 0 to sine inverse y 1 by 2 pi dx plus this point pi minus sine inverse y 2 to pi 1 by 2 pi. Now please tell me what will be the expression? Do the integration and tell me.
Pi plus 2 sine inverse y by 2 pi.
What's the name?
2 sine inverse
Pi.
y plus pi.
2 sine inverse pi plus pi.
Plus pi whole divided by 2 pi.
2 pi. So is it coming half plus 1 by pi sine inverse y?
Yes, sir.
Now this is for when y belongs to this. Now the other case, when y is, so this is case 1, this is case 2. Case 2, if y is a negative number, maybe somewhere here, what will be this value and what will be this value?
Pi plus sine inverse mod y and 2 pi minus sine inverse mod y.
So this one you can also write the pi plus you can write pi minus sine inverse y. Will it be okay?
Yes, sir.
And what will be this one?
2 pi plus sine inverse.
2 pi plus sin.
So now it is pretty easy. That integration 1 by 2 pi pi plus pi minus sine inverse 1 2 pi plus sine inverse. And tell me what the expression will you get?
One by 2 plus 1 by 5 sine inverse 1.
Yeah. Okay, so fx is half, fy is half plus 1 by 5 sine inverse y. Y belongs to minus 1 to plus 1. 0 for y less than minus 1. 1 y greater than. So quickly tell me what will be small fy? Zero otherwise. Well,
1 by pi root 1 minus pi.
1 by pi into 1 minus y. And now if I ask what is the expectation of y?
Zero.
0.
Correct. But how compute?
So we can put
Why?
expectation of x, sine of expectation of x.
Yes. So it is, you can go by this. So y f y dy, but that is not necessary. You can also go by this expectation of sine x, which is uh, sine x into, say, fx dx of, so sine x into 1 by 2 pi dx integration 0 to pi. So full circle complete. It is as simple as that. You need not go by this. So as long as you have a very simple density and some function of it, you go by that density. You need not always have to transfer the density and then integrate. That is not needed. To show this thing, I am just telling you that if you know the one PDF or PMF and you know a function of that random variable, you start from the very beginning of for which the density is given or PMF is given, then you go with that. Okay, 5 minutes time, another quick question. It is a very simple question. let us see that suppose you have a gate. Make everything open. So maybe here it is, here it is. No. So here is input, here is output of a signal, and you have name A, B, C, D, and E. What is the probability that any gate is open in action on? Off. Any gate is on with probability P, and that is 1 minus probability of off. Any gate, and they are independently identical. So now, what is the probability that E is on given the signal is received? At output. So the signal is sent from here and it is received here. That is given. You are interested to find out whether the E gate is open, on or off. Bayes theorem. Or the conditional probability. You should not do a mistake. This is a very simple most problem that we are doing. So what is the probability that signal will be received? And E is on and signal will be received.
Sir, is it p cube by p cube plus p square?
Which one? Denominator?
No, sir, overall.
Overall. So tell me part by part.
So upper one would be 2p cube.
Okay, let us consider 2p cube. Okay. Denominator?
2p cube plus 2p square.
P cube plus 2p square.
2p cube.
So what are the path you are considering?
So in the denominator it is 2p cube plus 2p square.
Okay. So what are the path you are considering?
Sir, AED.
AED, okay.
CEB.
CEB, okay.
And AB and CD.
AB and CD. I think this problem has some fallacy.
Sir, but it might be the case that AED as well as AB are both accessible at the same point of time.
Say again, please.
It can be the case that only C is off, so AED as well as the path AB is accessible at the same point of time.
AED and?
As well as AB.
AB. But if E is off, then AED will not be working, right?
Sir, if E is on.
If E is on, so either signal will go from here to here. We are not expecting that signal will bifurcate and replicate himself with a clone.
Sir, we cannot add probabilities like this. We'll have to union the cases. So many things will have to be subtracted from this.
Okay, tell me. No, I think the problem itself, I have not, uh, I have not seen the solution, but I think the problem language has some issue. So look, what I find here that it the signal may go from here to here, but E might be still open. Right?
Yes, sir.
This problem has some issue with language. It might be okay. That also can be considered. It can be open or it can be off. But A into B is okay. That's all right. Yeah, go ahead. Huh. So I think this will be the answer. Then 2PQ, these two paths, and in denominator 2PQ plus 2P square. So this is P by P plus 1. Okay.
Sir, I'm
Okay.
still having doubt in that portion, sir.
Which
Sir,
one?
what happens? Sir, what happens if only C is off? This case falls under both AED as well as AB. So how can we
Yes,
add
sir.
that twice?
Okay. One by one.
Yes, sir.
Please tell me. One by one. Please tell me.
Sir, please consider the case where A, B, E, D are all on except C. So C is the only gate which is off.
AED is on.
As well as B.
As well as B. Okay, fine.
Sir, but this case falls both under AED as well as AB. But this is a single case.
So A, you are saying A, E, D, and B. They all are on. Okay.
Yes, sir. This is one single case, but we are counting it twice because of the cases AED as well as AB.
AB or AB. Look, if AED path will be working, so either for both of them. B can be on or off. It doesn't matter. It can go by both of them, and if you add them up, you will get the probability of AED. If you add these two probabilities, you will get this one, right?
Yes, sir, but this value should be counted only once. But in the above four paths that we have written AED, CEB, AB, and CD, this path appears twice in the first path as well as the third path. I mean,
So
AE.
should it be more clear saying it can travel only one path? Like it can
Yeah, it can travel only in one path. I am not expecting that from here it will replicate, signal will replicate itself and it will come here and here. That is not allowed.
Okay, sir. So, like, we should consider these two as different cases.
Yes.
Okay, sir. Thank you, sir. It's clear, sir.
Okay, so one thing you remember that by I think by Saturday you will get the login password of your exam. If you don't get it, positively inform me by Sunday. And if you get it and still you have difficulty to log in the Moodle, you check it whether you can log in the Moodle or not with that password. Then also you inform me by Sunday, because Monday is your exam. There will be no class. and try to get login within time. Okay. So that's all the best. I hope there are enough material for your practice, and we have talked about how to deal with the problems as well as the practical issues with data analysis and theoretical aspects. I think many of the sections has not covered as much as we have covered. Hopefully it will be helpful for you. Okay, thank you so much. All the best.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.